46. Let xy be any two sets. Let tau of y to be a topology of y. Let there be a function that maps from x to y. Prove that tau of x is a topology of x. For the first goal, we have to prove that x and the empty set is in tau of x. So let x, the empty set, be in tau of y. Then we know the inverse image of the universe and the inverse image of the empty set is still the universe and the empty set, which is in tau of x. And with that, we're done with part 1. So for part 2, we're going to prove that the unions of the members of tau of x is still in tau of x. So let A be a collection of members of tau of x. So we denote that AJ is in tau of x, where we have some sub j and some j. And we define AJ to be the inverse image of B of j, where B of j is in tau of y. So in this case, if we take the unions of AJ, that's the same thing as taking the unions of the inverse images of BJ. And from previous modules, we know that the unions of the inverse images is the inverse image of the unions of the sets. And the unions of B of J's is the whole topology itself of tau y. And that is tau of x. And with that, we're done with part 2. So for part 3, if you have any two sets that's in tau of x, the intersection of tau of x, and the intersection between two sets is also in tau of x. A1, A2 to be in tau of x. So we know that A1 is the inverse image of B1, and A2 is the inverse image of B2, where B1, B2 is in tau of y. So if we take the intersection between these two, this will equal the intersection between two inverse images. And from a previous module, we know that the intersection between two inverse images is an inverse image between the two sets. And we know that this whole image is in tau of x.